Well, good morning, everybody. As we start off a new month here, I thought it'd be good just to look back at January and get an idea on the precipitation and temperature ranks, just kind of understand how that month kind of progressed. And so we're going to look first at precipitation ranks by climate district. Again, this is out of 132 years. So anything in the single digits would, of course, be a top 10 wettest. And then if you get up there close to 132, you'd be driest. And of course, one of the bigger issues this year compared to last is just the complete lack of flow that's come through the northern plains of the United States, the upper Midwest, and also into the Canadian prairie. This left this area well outside of normal snow, and we're waiting on the pattern to kind of change and develop more of a polar branch to the jet to deliver to this region. But nearly everywhere else in the country has seen better moisture or is about to see it. I'm thinking right now about what's going to be changing in the Southwest. And another area that's kind of been missed lately has been here, just this kind of eastern side of North Carolina, South Carolina, and part of Georgia. Outside of that, we've had a pretty wet go of it for much of the country. Now, thinking about this another way, I did want to show you the latest percent of normal snowpack map, because this will be changing a lot over the next several days. And we're going to see these numbers really start to come up in the Sierra Nevada, throughout the Great Basin, into parts of the Four Corners states with the onshore flow that's coming with this extended Pacific jet. It's also probably going to be changing here in just the corner of the, of Maine with some heavier snow, but I honestly don't see the pattern evolving in a way in the coming weeks to really hit parts of the northern plains hard. And I'll just be honest with you, earlier in the season, I didn't think the northern plains would be left this far out of the pattern, just thinking about what we were saying back in fall about how winter was going to shape up. And so, if anything, we're going to have to wait on a late winter shift in the pattern to really give us anything here. And what that is that's just a return of southwest flow that's going to have to come through California and out like this. It's got to come with troughs in the northwest that eject into Wyoming and Colorado to return the moisture to this area. Now, we could get that later in the year. Remember, for most folks in the northern plains, we do have some years where we get a lot of our seasonal snowpack that adds up in March and even early April. I'm not saying that's going to happen this year, but just a reminder as to where that can come from. And to be honest, we need it. We need to get something in this area soon. So we'll be looking for kind of the catalyst in the pattern to kind of get things changed here in just a few moments. Okay, from here, I want to show you where we currently have snow on the ground and how much water is in it. Now, we watched this map evolve over the last several days, especially in the midsection of the country, as as the warmth came in. And I'll anxiously be kind of waiting to fly home today. I'm in Reno. And we're gonna fly. I'm gonna fly to Dallas, and then when I come in, I just want to see how much. As I come into Chicago tonight, just to see as sun is setting what snowpack looks like from the plane. It'll be interesting just to see this, but this would be NOAA's estimate on current snow water equivalent. Now, with the melt that's happened here, plus the extremely heavy rains over the last 10 to 12 days that hit parts of the Mississippi Valley, Ohio Valley, just want to bring up to speed again today. The Mississippi River is about to crack 20 feet above low stage, so just in the span of about 13 days, it's gone up about 22 feet in total depth. So again, this river is going to continue to rise as more of the floodwaters go down. Now, what we've got next is just to look at our last 7 days of temperatures, because the last week of January is going to really kind of offset what most of January gave us. So remember, we had a mild start, and then right away the temperatures plummeted for about 10 to 15 days in some locations. Then we finished the month on a really mild run. So all the cold air went back to Alaska and Greenland. I know you've heard me say that about 1,000 times, but that's just where it's been stored for the last bit of this month. And but the whole month, when you look at it, is going to favor the last time that cold air came out of Alaska, which just dove into the center part of the country here. So statistically, in other words, looking back over the last 132 years, this is going to be remembered, as a January with a very, very cold bias in this section of the country. And it's just a reminder that sometimes when we use monthly based statistics, it doesn't capture the variability, especially during winter, of what the temperature pattern can often do. So we just have to keep that in mind, and when we look historically and then use historical analogs to look forward, okay? So from there, let's talk about kind of the two big systems that are going to be, I think, focused on in the next about 7 or 8 days. This is a water vapor loop, so we're just looking at upper atmosphere water vapor loop. It's actually an animation that's made using infrared temperatures, but a very specific band where water vapor does absorption. So it kind of gives us an idea where there's high water vapor content and low. And you notice here's the large storm system we just watched, and the frontal boundary has come right here into the west. It's oriented north-south, very strong winds. And here's the newest one that's starting to curl up. See, there's moisture from the south of it. It's getting pulled into this deeper low that's sitting and spinning right here at the end of this animation. That'll be the one that gets us late in the weekend and early next week, and it's going to be much farther to the south when it gets there. I'll show you why it's going to be to the south in just a moment. There's a neat story there. But through this morning, this is our kind of national radar loop. It is color-coded for precipitation type. Snow levels did come down to about 5,000 feet in the Sierra Nevada mountains, and we're adding up possibly another 12 to 24 inches with this first system. The big push, the one that could bring in a lot of snow, is the second big pulse. But you notice into Southern California, extremely heavy rainfall here. We're going to get some updated totals on what to expect out of total precipitation coming to California here in just a few moments. I did want to show you, this is a public Twitter account, so we can view it all together here. But this is looking at the Oroville Dam, which I understand has been opened just in preparation for for the release of water now, so that when all of the moisture does accumulate, we are not going to be stressing the dam, the spillway, and the water resources in and around this area. But this will be a very tricky next couple of systems to manage with respect to water across California, given how, not fragile, but how, to be honest, the water management in California is fascinating and it's challenging. I mean, that's all I can really say about it. So it'll be interesting to see what goes on here. Okay, last 48 hours through 7 a.m. this morning Central Time. I'm out on Pacific Time here, so a bit earlier for me, but we can see that we've already had, just in the last 2 days, some of the rainfall totals right here in coastal California, have gotten up to, we're over 6 inches of accumulation already. Now, these maps have about a 2-hour lag, so if you ever look at them, you're like, wait a minute, you just showed it was raining in Southern California. Even though I say it's through 7 a.m. when the map was made, there's about a 2-hour data lag in this. So that'll also show up on my website, just as a point, a note there that I want you to remember. But here we go. This is it. There's the new low that's curling up. There's the deep one we just watched. Here's the strong flow that's supporting the heavy rains in Southern California this morning. But the atmosphere is getting all spun up here in the North Pacific as the jet just continues to go. And it looks something like this at the jet stream level. And here we are looking at winds where the pressure is 250 millibars. So we're about, you would say that's about 75% through the thickness of the atmosphere. And it's called the jet stream because it's literally at the height at which jets fly. And again, there is the extension we've been discussing so much in the split right there, really showing up well. It's always funny to just think, wow, we've been talking about this for so long. It's feeling an old hat, but it's just now finally occurring. So a good job on the models at seeing this, several days in advance. Okay, so putting it just in broad brush strokes here, the next 10 days looks something like this from the operational European model. We know that because the flow is going south, it's going to leave a lot of the northwest out of the flow, so we're drier here. The latest European model run wants to kick out some better snow in this area, and wants to kind of fire off a couple of systems that the previous runs did not do. But overall, if there's a drier spot, it's here in the Ohio Valley. It's here in the mid-Atlantic down into the Carolinas and up through parts of New England, drier than average. We're also a bit drier right in through here and possibly in parts of the upper Midwest. So it's just giving us an idea. But we do see that compared to average, there will be parts of California that could pick up anywhere between 2 and 4 plus inches compared to the climatological normals for this time of year. But as you would expect, the 10-day temperature pattern looks very much like we've been talking about, with a lot of coldest air going back to the Arctic. And until we get some sort of significant Arctic ridging, we're going to keep it there. So most of the next 10 days continue to stay mild while the west goes a bit cooler. Same thing with parts of Florida going a bit cooler than average. So some details on this. This is the morning's all hazards weather map. Saw more fog showing up here, right basically on top of where that snow is and where it's melting. And we see some high wind watches that have been issued down in this part of Texas and New Mexico. There's also strong winds expected throughout California. And we have everything from flood watches to wind advisories to winter storm warnings. A lot of, a very colorful map here across parts of the western United States. So let's go ahead and look at some high-res models, and then we'll kind of pull this out longer by looking at some probability maps, So today, we watch the pulse of moisture coming through Southern California. It gets into Arizona, New Mexico, eventually after going through Utah and Nevada. And then just note, we do have light precip that's moving along our frontal boundary stretched here, with some light snow in parts of like upstate New York getting all the way to Maine and into the Canadian Maritimes. Now there is a boundary, a frontal boundary sitting right in this area. And that's going to be a kind of a barrier over which we're not going to be able to get a lot of this precipitation from this first pulse. So here we are now through Friday afternoon. We're going to watch Friday evening for storms to pop up down here in Texas and Oklahoma. But you can almost see that frontal boundary in the model. And what's going to happen is the moisture is going to try to stay south of it, but get pulled back into the plain. So there might be a little bit of upslope flow here, which is why we see some snows getting added before we get into the next big system on Sunday, which is here. Now that next big system that's coming through, we're going to look at two different models for it. And I just want to remind you something I brought up all week long. Remember, we watch the model performance and understand that at times it performs quite well and then collapses. And then a good stretch collapses, good stretch, and here we are again. And you can actually see the GFS model really dropping off in its skill score compared to the European. So just something to keep in the back of your mind. And since I talked about it all week, I thought we'd look at it again. But I did get a good question in the comments on the YouTube site about asking me to explain the Fujiwara effect. Okay, don't look at the map in the background, but I want to show you something. Just imagine you have, I'll just draw over here, you have a low circulating like this here, and then you have another low circulating like that there. These two low pressure systems cannot combine. They can't come into one another. And the reason is, if you just kind of think about it, we'll just kind of draw this a little bit differently. So that would be the flow around one low. We'll start the arrows here, and that's the flow around the other. Now, you can see that they're both spinning in the same direction, right? But can you see how there'd be a canceling of their flow right in the middle? So what we end up finding is, instead of a canceling, they tend to pivot around the middle point. So one low comes out like this, and the other comes around the back like that. Okay, that's the Fujiwara effect, discovered in the 1920s, looking at tropical cyclones by a Japanese scientist named Fujiwara. That's where it comes from. Now, let's come back over to the map, because what I'm going to show you here is vorticity, and it's looking at spin in the atmosphere. And as I play this forward, the vorticity pattern I want to pay attention to is the trough that's off the northwest, and then the second low that's coming in here on Sunday. So it's just off the map. Now watch this. As we get a bit closer, here are the two lows. Now I see they're not perfect circles, but there's a low here, and there's a broader low there. And that pivot point tends to be right between the two. So what's going to happen here is this low, compared to this one, this low here is going to allow the western system to pivot and drop farther to the south into California. So as we go forward, see how it gets flung around there? So here we are now. This low didn't move too much, but this one has been elongated and forced to shoot kind of to the south, enhancing its capability of lifting air in the atmosphere as it targets California. That's been the main enhancement of this next system. I should have mentioned it earlier in the week, but that's what we're watching. It's a really interesting combination of events that takes place. So we're up to Monday, and now we see, watch, this low here was the one that started there, so it moved in that direction. The one that was over here went all the way around the base and is now flung into the western United States. So see the pivot that they did around that X I drew. So getting out there to next Tuesday, Wednesday, Thursday, that is when we see, the depth of this low finally finish its push into the western United States. And this is going to be our kind of, I would call this our third and final push of really heavy precip by the time we get into next, Wednesday, this upcoming Wednesday. All right, so let's now take a look at what this all means. And we're actually going to get to see the Fujiwara effect in the models. So we've watched already in the high-res NAM the projections through Thursday into Friday. We see the frontal boundary stalling out, so there's your heaviest precipitation. This is now getting into Saturday night. And we're going to watch the snows kind of get added up here along the front range of the Rockies from just Colorado clear up to Montana. Now, the Fujiwara effect, I almost missed it here, is happening here and here. Now watch. Let's go back just a couple of steps. One low's here, one is off. You can see it in both models. And you're going to see that southern low just get tossed. See it get tossed into California? Can you see the pivot as I rock back and forth? I'm watching right here. Kind of a neat thing to see. And then remember, we have the final push coming around the base right there next Tuesday, Wednesday. So if I could show you the whole thing starting on Saturday, this goes into Sunday, Monday, Tuesday, and Wednesday of next week. And during that time frame, there will be another low that curls up over the southeast, and we've talked about this, Monday into Tuesday. And the models aren't sure where that's going to go. Now, you know that the skill scores have dropped off for the GFS. So based on that alone, we would say that this would be the less likely scenario, and this might be the more likely scenario. But what you see is that the European model leaves that wave out to open ocean. The GFS wants to have it race right along the coast. So we need to pay attention to that carefully, but that's going to be a discussion for tomorrow. I'll watch it over the weekend and we'll have a better idea early next week, because we're talking about next Wednesday, Thursday for that time frame. Okay, do notice that the models are trying to toss something out into the northern plains late next week. I don't have a lot of confidence in this yet. Okay, I'm just rocking back and forth between next Wednesday, Thursday, Friday. So I'll keep an eye on it. We'll look at some probabilities in a second. But how about some model comparison? This is the WPC 7-day forecast, and we see that precipitation amounts, liquid form, will easily get up here in this, maybe in this 4 to 6 inch range, maybe even a bit higher in places. And it's also going to be very wet into Southern California. Notice we have a large area that's not expecting much out of this in the next 7 days, and that's also mimicked by the GFS and also by the European. So we've got 3 different models, 3 very similar patterns, although there are some differences. Like, look how much wetter the European is here. In fact, we can do that by just comparing the models. Using the 0Z runs, the European model with that second system that gets tossed around the southern edge, we just saw the Fujiwara effect. It's actually trying to put in much heavier rains. Compared to the GFS, maybe up to 3 to 4 or 5 inches more than the GFS. Now, we know these are just model totals, so we have to take them with a grain of salt, but they're a good indicator on what could possibly happen. So from there, let's look at the snowfall, and this is just a national map, including a part of the Canadian, southern Canada, to see how much snow we're expecting. And one thing the models did come into a better agreement about is the snow in Montana that's going to get into parts of southern Alberta and Saskatchewan here, because that's the European model, and there's the GFS, and I see some similarities in this. I would not trust a single snow map right now to give you any sort of an estimate on how much. So that's why I didn't give you the details. I'm giving you the bigger picture, because forecasting snow out of this, thing coming out of the subtropics is going to be very hard in the western mountains. I just will make note that in both models, the European and the GFS for the Sierra Nevada, they are going over my color bar here, suggesting, better than 4 feet of snow, which I think is possible. So we'll leave it at that. And what I want to get to next is just a tool that I want to make sure you're all aware of. So I'm in Reno. I know several people I met at this conference yesterday are going to go to Lake Tahoe. So if you come to my website, agweather.com, and if you want to just see the raw model output, come over here and you can just start typing in. So they're going to go to Lake Tahoe. The town I've got in here is South Lake Tahoe, and it puts the number 1600 in there. And that's just because when I index my 30,000 city database, I base the index off the size of the city. So it's not 1,600 people, it's the 1,600th largest town in the United States. So click submit. It'll take you to another page really quickly here. Well, I got a slow internet connection. There you go. You click there and you get your forecast information. So as we click on this, there we go. What you've got now is kind of current conditions, a broad radar, and you can even look day by day. But what's kind of fun is to come down to the bottom where I have a lot of statistics and also forecast. So right now, South Lake Tahoe is a bit above average in terms of precip from some early season events, but you can see the incredible spread and precipitation they can get. Now you can do this for any town in my database, play around with it. But what I wanted to show you was this one, the 10-day ECMWF and GFS snowfall. So click on that. And this is just it's impressive, but remember, this is 10-to-1 ratio in the models. So right now, over the next 10 days, here's the push of moisture today. Here's the one that comes in this weekend, okay, Sunday into Monday. The European models got them at 49 inches of total snow. You can actually just follow it along if you want. And then the GFS has them at 50. So there is a chance that they're going to get a lot of snow in South Lake Tahoe. But feel free to do this for any city. And I'm just going to put a disclaimer. All I am doing here is I'm presenting raw model out, because I find it much easier to try to assess and understand the timing, the amounts, by looking at several models together. So you can actually even look at this, the 10-day multi-model temperatures. You can look at the precipitation from 3 different models here, include the NBM, to kind of get an idea on when and where. And I hope it's a useful tool to everyone. So play around with it. It's free. It's on our website, agweather.com. That's sponsored by Nutrien. And it's a great place to go to get information. But what we really need to do is not look at individual runs and instead look at ensemble numbers. This is where skill comes into forecasting, okay? So I wanted to find the drier side of this first. So we come over here to parts of Mid-Atlantic down to the Carolina coast. You see also parts of in the coastal region, of New England here. Lowest probability for rainfall. This is less than 1/10 of an inch. You can also see that the upper Midwest has been shrinking in this amount. So let's now go to the wetter side of things up to an inch. So this is the probability of getting over an inch of liquid out of the atmosphere. Of course, a lot of this will be snow. Let's go up to 2 inches. And what I tell you that the models have trended more toward is the heavier rains here in parts of the Sierra Nevada. Well, this is going to be snow, but heavier liquid amounts in the atmosphere. And then right here along the coast. So I am expecting pretty significant flooding issues in California as we press forward. And if we do step this up to 8, we have some areas right in through here that have a 50% or better chance of getting more than 8 inches of liquid out of the atmosphere in the next 10 days. So there's a lot of moisture coming in, and this just kind of shows us what to prepare for. Let's go over to the snow side of this very quickly, and let's just go right to some of the bigger amounts. How about more than a foot? We can just keep stepping this up. There's 18 inches, 24 inches, 36 inches, 48 inches, and you notice that it's only when we get to 48 inches that we start to see the probabilities drop off below 90% for the Sierra Nevada. If we're looking at who's going to get any snow, this is the newest chance for getting an inch, so new kind of changes in the models in through this area, and here's the chance for 3 inches. So just a good way to kind of think this through. Now, as you know, what we are watching most carefully beyond day 10, if you've been keeping up with the videos this week, is that as we move to February 12th, 13th, and 14th, we're starting to see this ridge that's building up the West Coast. Now, it's not the best setup to deliver cold air or rip off big storm systems up the East Coast, but it's not a bad setup either. You know, what would be ideal if you wanted to see big storm systems here is we'd have this ridge more in the Bering Sea, over here in the Bering Sea, or more toward Japan. I'm sorry, that's a trough, forgive me. And that would take the ridge and put it right over Alaska. And if we had the orientation not like this, but like this, you get deep troughs in the Northwest, and they would just eject. And that would be what would cure the issues in the Northern Plains without having good moisture. But what I do notice is that for the second part of this month, we start to get higher heights building into this area. And that's a signal to dislodge some colder air. It's not a perfect signal, but it is a signal. But with that trough moving, first let's talk about precip into week 2. And this is what you've got from the CPC. This is from the European, and this is the GFS. So driest compared to average will be the Northwest, which is out of the flow, and the ridge builds in. We see California gets a break once we get out there fully into week 2. I think the European was the first to pick up on this. We'll probably see the other 2 models reflecting that once we get their new information later today. But it'll finally be a bit of a slowdown for the West as the ridge builds in. And we'll need to pay attention to what happens next in terms of getting stuff farther to the east. Now, back to the temperature discussion, I want to show you that right now, the polar vortex is tightly wound up, and it's just sitting right here over this part of northern Russia. But there have been some forecasts that want to take that polar vortex, again, which is centered here, and maybe, this is the GFS run, maybe not through the beginning of February, not until we get out there to the 9th and 10th, 11th and 12th. I mean, we're way out here in the forecast. But some models out beyond 300 hours, which we know, we jokingly call La La Land, are trying to do something weird by just shoving a large ridge, we call this a pressure perturbation, just shoving it in, splitting the polar vortex up. But I'm going to be just honest with you. I'm on an operational model run at 372 hours, and this is just, okay, we looked at it. I can't ignore it because it's a sign, it's a signal. But I'm looking for any reason to displace the cold air and get some kind of cross-polar ridging here, not just in the stratosphere, but in the troposphere, for a signal for getting some cold air to come leaking out. But it's not that strong, and it's also not strong in the tropical connection. You know, we got to get the MJ out of here. It's got to come around. Phase 8, 1, 2. It's got to sweep back toward the Indian Ocean. And the model's like, no, just stall this thing out right in this area. So I say all of that to let you know that the upcoming pattern doesn't have a whole lot of change in it in terms of what we've been discussing for temperatures. My good friend Arlen Suderman's heading home today. Arlen, if you're watching this morning, 67 degrees by the time you get home. I'll go ahead and take credit for that. But as we watch here into Friday and Saturday and Sunday, just mild air occupying so much of the upper Midwest Northern Plains, that'll melt a lot of snow. We get out here into Monday and Tuesday and Wednesday. And my claim on having an active back half of winter, my goodness. You know, we had 10 days of it, and we're back into very, very mild conditions overall for a while. So what does it look like beyond that? Well, here's that 5-day sliding window of average temperature anomalies. That's day 5 through 10 from the European model. And even as we get out here, day 10 through 15, We're still waiting on the evolution of this pattern until the very end of the month of February to possibly deliver some colder air. So I'll be watching this, but my narrative is not going to change in the long range until something breaks, either in the Arctic or in the MJO, to give us something different here. All right, from that point forward, I want to give you a quick discussion about Brazil and Argentina. And I want to show you, this is a resource from USDA. I really like it. They've updated their webpage. It's really kind of nice here. So this is using individual countries, which you can select from this drop-down menu. I'm in Argentina, and you can pick the crop so we can see where it's grown. So you notice that if we think about 90% of the soybeans are grown here, okay? So this would go from like Entre Rios over toward Cordoba and Santa Fe into Buenos Aires. Or if you flip this over to another crop type like corn, you're going to see, there we go, kind of that similar area, but a little bit more is grown a bit farther to the north. Cotton is grown up there, though, so we kind of switched this around. There's quite a bit of cotton acres here in the north. I bring this up in Argentina because we're expecting some hot conditions down there. And rather than show you precip totals, I thought we'd do some probability forecasting here. So this is the chance at getting the temperatures over 100 degrees. So here's today's chance. Here's tomorrow's, getting into Saturday. No, I'm sorry. That was Friday's chance. This is now getting into Saturday. So notice we're going to hit some cotton acres pretty hard here in the northern corn belt and soybean belt in this area. And we just play this forward through the weekend. You're just seeing flashes of it because remember, these are only reflecting the afternoon heat. It's going to be deep in the 90s with highs well above 100. This is all the way to next Thursday, the 8th. And what we're going to watch for is these probabilities to drop off after the 8th. And they are. So that means we've got a solid 8 days of incredibly hot temperatures. And while that's happening, the chances of staying drier are high. This is the probability of having less than a half inch of liquid out of the atmosphere. So there will likely be some crop stress in this area. Is it going to knock national yield numbers way off track? I just don't think so. I think it's got to be longer duration. And it also had to come into an area that just didn't have much moisture. And the drier spots are in Buenos Aires and pockets of their cotton belt. But I just wanted to point out that there will be some crop stress here. I've been a bit cautious in trying to determine just how much in Argentina, because we are expecting the Argentinian crop to come back, to what it normally should be for all the major crops, given the rains early. Okay, who's on the wetter side of this? This is a 10-day probability, if it ever loads, there we go, of getting an inch. This is 2 inches, and this is 4 inches. So we're looking for this stripe of heaviest rainfall still hitting these areas that are trying to harvest soybeans and plant safrinha corn. So there's a 50 to 60% chance of getting another 4 inches of rain just in the next 10 days across Brazil's northern growing areas. That is going to be a story to continue to watch through February. It'll be interesting to see if it slows harvest progress down at all and what it might do to the planting pace. So we'll watch it carefully, and any new updates I get in the long range, I'll be sure to share with you. Have a good rest of your day, and we'll talk tomorrow. Thanks.